He has not defined G, no? So let me take that one. In space it is. Okay, look at something is asking efficiency. Develop suitable expression for efficiency of propulsion. So let me define few terms. What is lambda? Lambda is the rate at which fuel is burnt. Now then, what is the velocity of this? Is the ejected gas. So what is the velocity of ejected gas? So this U we know. So this will be U equal to VE minus of minus V. Why it is? Because I'm taking downward as positive. The velocity of ejected gas, velocity of gas ejected with respect to rocket is U. Velocity of ejected gas with respect to ground V. That of the rocket is this one. So this will be U minus V equal to V. So what is V? Velocity of ejected gas with respect to ground. U is velocity of ejected gas with respect to or relative to the rocket. So these are the initial things. Okay, let's come for the what is useful power here? The thrust force. So useful power is the thrust force into velocity of the rocket. What is the thrust force? I think already you know. This should be equal to U lambda into V. Can you remember this? The formula is like this, no? U dm by dt Vr. This is U dm by dt. If I solve it, how much I'll get finally? Lambda into V. Now come for this one. What is useful power? This should be equal to U lambda V. Oh, something lambda. This is dm by dt is the rate at which fuel is burnt. So this dm by dt you can also write it as lambda. So U lambda is what? This one. So what is the useful power? U lambda into V. Because this will what? Will impart momentum for the rocket. Now come for this one. What is this gas? The ejected gas will have some momentum, will also have kinetic energy. So what is the kinetic energy of ejected gas? Kinetic energy of ejected gas, this should be equal to K equal to mass of ejected gas by speed of ejected gas, VE, that we have calculated. So this should be equal to ME U minus V whole square by 2. Now this particular gas, ejected gas, will have a mass. Am I right, all of you? That will be. So now is it continuously ejected? S, the rate at which the kinetic energy of the gas varies here. So this, if I differentiate, dme by dt, keep these terms as it is. So dme by dt or dm by dt, what all if you want, you m again you should not. Okay, this one, yeah. I'll retain symbols here. Let it be here, this one, mass of ejected gas. So this should be equal to lambda u minus v whole square by 2. Fine. Now what is this dke by dt? Wastage, power or energy. Any use of this ejected gas, nothing, no? That much of power is what? Will be lost here. So then how we define efficiency? This is a useful power. What is useful power? The power which will impart momentum to the rocket by total power supplied to the rocket. Total power supplied here. So what is useful power? U lambda V. What is the total power supplied? Useful power plus power due to wastage or wasted power. So substitute this u lambda v and lambda u minus v whole square by 2. Solving this will get an answer 2uv by u square plus v square. So this is the efficiency of the rocket. Efficiency will put a symbol eta. So like this, the efficiency of the rocket depends upon the relative speed with which gas is ejected and what velocity the rocket will acquire. So usually practically what is the efficiency? It will come around 70%. It's very good. You look at the jet airplanes, no, the efficiency is only 40%. Maximum efficiency is what we have 74%. And in India, the maximum efficiency achieved is 72%. In the French or you can say like a Americano, when they launch it's 74%. Our Indian rocket 72%. It's very good. Because the fuel is costly, we have to save money. So there's a maximum possible efficiency till date 74%. Can be asked here something power related here. So no concept. I already have some basic background that you should apply in proper way. Now this already we discussed. No? Next, chain. This is a very basic fundamental problem. A chain of length L and mass M I'm going to lift it from the ground. It's asking what should be the magnitude of force and what is energy lost in lifting it. Why energy will be lost? I'm using word energy lost. After getting answer, we should justify where do that energy gone, not just simply by ending up with mathematics. So on the ground, on the ground, so here the chain is lying. The chain, what pen better to show links. There's a method what in the books also they're shown. Now I'm going to lift it up. Yesterday it was falling chain. No, now I'm just picked up a problem, rising chain, and also will bring the energy idea into the picture. So this part of chain will be a test. Here I applied a force. So that this P momentum, you'll get confused. I'll write F naught. The force is what I applied it. Now let Y length of the chain be above the ground. Then I'm going to lift it up with a constant speed V. V naught. This is also given. Let's get into the problem now. First of all, what is this force? I want this force. What are the things that will act? How to calculate force? Any thrust force will act. In what direction thrust force? So now again, immediately the thrust force will come. So what you should do? You should take help of the link. No. So there's a link which is at rest, which will about to enter the vertical part of chain. So what will happen to the vertical part of chain as the Y length increases? The mass of system increases. No. So now what is the system? The vertical part of a chain is a system. So always you should be better position to define what is the system here. Now we are not bothered about the chain lying on the ground. The chain that is being lifted. So this is a system. So it is having a velocity v. So this link will enter into the system. So the mass is getting added up to system. The mass which is getting added up, what is the state of it? Rest. So get into the problem. So this S is a system. So here first, I think we do like this. Velocity of the P. This is the link. Vp equal to Vp minus Vs. What is Vs? S is the system here. This velocity is what I have to find out. Velocity of point P, 0. That of this plus V naught. In what direction the velocity of the point P when it's getting added to system? Downward. So this is what VR will write it, no? Show that we are in this direction. And now, if the mass of system increases, what direction the thrust force should act? In the direction of VR. So here is what? The thrust force. Agreed, all of you? There's a method what we followed. Now, what is the total force I should apply? F naught plus weight of the vertical part of the chain. How much? Lambda Gy plus thrust force. How to calculate thrust force? What is the basic formula? There's a chain at rest on the ground. How to calculate thrust force? That should be equal to VR into dm by dt. Dm, what you can write? Lambda into dy by dt. And VR equal to V naught. Dy by dt should be V naught. So lambda V naught square. This is the external force. Huh? External force acting on chain. Now, look at this force, constant or variable. It's a variable, no? So let's do one thing. Work done by external force in lifting the chain from initial to this particular position. So it will apply constant or variable force. He will apply a variable force. Look at this lambda Gy. Variable force. Then it will do work. Then Y will, what is the displacement? So this end is what is holding here, no? This end of the chain. First he'll hold this link and it will start rising up. What is the displacement Y? So you apply constant or variable force, a variable force. That's the one thing. Then what happened? All that, what all it did work. A part of it is used to rise the potential energy of the chain, gravitational potential energy, because center of mass of the chain got lifted up, no? So increase in gravitational potential energy of vertical part of the chain. This is the one thing. Next again, kinetic energy of the chain. There will be some mechanical energy will be lost. What all it did work, a part of it converted into heat. Why do that heat will come? See, all of you have seen chain. These are the links, no? So when you start lifting up, what happened? One link will collide with other link, and look at this particular link. How they should move? They should move like this, no? The link is at rest. After some time, what happened? This chain will be here. So the link, what happened, will rotate like this. So when they're rotating, so definitely one link will collide with other link. I think you'll get some sound, no? Dug, 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 something, or any other sound you can generate. You try to check that one, any chain available, no? For suitcase, lockers, wedding, no? That chain you keep like this. Try to lift it, no? You get some sound, some humming sound, what we call. Why that sound? There is nothing but the loss in mechanical energy will convert it into a sound energy, and a part of it will also be heat. So therefore, there is some sound energy generated, means there must be some loss in mechanical. That loss in mechanical energy is asking. Got the idea, no? So work done by external agent, we'll write it here. Should be equal to increase in potential energy of, increase in gravitational potential energy of chain plus kinetic energy of chain plus loss in mechanical energy. How to calculate work done by external agent? So this integral of f d naught, increase in gravitational potential. So look at this. What is the mass of vertical part of chain? Lambda y g y by 2. Where center of mass is, will be at a distance y by 2. Kinetic energy of the chain. What is the mass of the chain? Lambda y to v naught square. This is what? Delta E. Substitute this, solve it, you'll get expression for delta V. Where do this energy? In the form of sound and heat. Why do sound will come? When links collide. So they say humming sound, like a gasping sound they call technically. So this now will integrate here. F naught is what? Lambda Gy. So this will be lambda y v naught square by 2. This is what? Loss in mechanical energy. Can you calculate this? It's only integration. No? I'll go to the next idea again. No? I'll give the answer, verify it here. So delta E, this should be equal to lambda v naught square y by 2. In the form of sound and heat when the links collide. So therefore, I think when we are working some problems with the variable mass concept, we have to be very careful about the some work done, some heat will be generated, some energy will be lost because the thrust force will come into picture here. Now take the next one. This you can do it. I'll take the read the question. A railroad car of length L and mass m naught when empty is moving freely on a smooth horizontal track. It is loaded at a constant rate. Q is telling. Instead of lambda, he has brought that Q. There's no external force. It was moving with a velocity v naught. Now, what is the overall the idea of the problem? So it is take like this, So this is a fixed here. Let initial mass be m naught of the truck. Let's take this one here. Already we have discussed problem. Just some conservation of momentum is what I'm going to bring. No. So this is the same. That particular hopper, or it's called as a chute. So that position of that will not change. Now where the truck will be. So the truck, let it be somewhere in this position. Try to see this now. So this will have some velocity v and some mass got added up, no? Some mass was getting added up to the system. The speed of car v at the instant when the car has cleared the chute. So some let it be x, that one. I'll take this is. Okay, let's write down the equation. Oh, inward action, the thrust force all. So I'll say net force acting on system. System means what? Mass getting added up and the trolley will become system. The mass which is getting added up. So inward action, the velocity of that added sand with respect to trolley. Yesterday we have done this, if you can remember. Vst equal to Vt. So velocity of sand with respect to trolley. This we don't know. Velocity of sand 0, no? And velocity of trolley is V towards right. And velocity of sand with respect to trolley is Vr. So what is the direction of the mass which is getting added up? It will be, okay, I'll shift it a little bit up. Huh? Once again, I'm repeating what we did earlier. So here the mass which is getting added up. Inward action, it will have relative velocity, Vr. So and mass of system is adding up. So therefore, inward action, the thrust force should act. The thrust force will act here like this. Now, will there be any thrust force on the particle also? Yes, it should be no, because Newton's laws of motion equal and opposite. So therefore, what is the net force on the system will be 0. So to avoid confusion, I'll just remove it. Let's get into the problem now. What is the net force acting on system? I'll say 0. What force the added mass, what the mass which is getting added to system will exert? The same force, what happened? The trolley will exert force on this particular mass. Now, what is the system? Trolley plus this is the system. The mass which is getting added up to system and the trolley is that one. So let the total mass of system, let it be m. Now because m naught plus some mass getting added up here. Okay, let's write the equation now. What is the net force acting on system? I'll say 0. Sir, what about thrust force is acting? What thrust force will act on the trolley? The same thrust force will act on the mass which is getting added up to system. So then, so what is the basic equation here? M dv by dt plus v dm. You have to think in this way. So m dv by dt. This dv by dt is what? Acceleration. This is what? V relative. Or nothing but VR, that is VR. So what is dm by dt? Dm by dt is what? Q. This acceleration, I'll write it as V dv by dx. Okay, able to understand now? This will be, so this will be, keep as it is, don't change it. Now, what are the things like? We have to calculate the speed of this one. No? So what is mv? Initial momentum was m naught v naught. Final momentum was mv with mass get added up. Initial momentum equal to final momentum, as net force is 0 along x-axis. So therefore, m naught v naught should be equal to mv. What is m? M is mass of the trolley plus mass of the sand got added up. The total mass it is. So this mv, I'll replace it here now. M naught v naught dv dx equal to minus v into q. Solving this, dv by v is equal to q by m naught v naught into dx. I'll write it below a little bit here. dv by v minus q by m naught v naught dx. So now this integrate. Initial velocity is v naught. Finally, when it attains velocity v, 0 to L. Is asking the velocity finally when it attains, no? When x equal to 0, it was it. So finally what happened when the rear end of the trolley reaches the chute, or say this particular hopper, that one. So x equal to L. Solve this. Log of Vf by V naught equal to minus QL M naught V naught. Okay, this is the expression for the speed of the truck when it is finally ended up. That one. I'll give a rough diagram. The idea of conservation of linear momentum is very important. Net force is zero, in fact. But sir, earlier you didn't do. If you take only trolley, because of that thrust force only, the velocity will change here. Okay, no. So this is the overall things. How to calculate this total mass now? MF. Applying conservation of momentum. They're very important actually when you go for some applications. So this is the idea of the problem. The net force acting on system is zero. The force acting on, say, why the velocity of the truck will change? Because of thrust force again. Take next one. Yeah. What force, thrust force is acting on the truck, the same force will be acting on the mass getting added up. Net force will become zero. That's why momentum is conserved. There's a rope and a block. So slowly we are moving to some applications like a laws of motion one. A smooth rope of mass and length lies in a heap on a smooth horizontal floor with one end attached to a block of mass. The block is given a sudden kick or some impulse is applied. It starts moving. I think the entire numerical is this is a block of mass m. It'll be connected like this. Huh? EP is telling. One end of the chain will be connected to the block. So finally the EP will be, these are the links. Some X length is here and this is that point P. So what is the state of this EP? This will be called as EP. Get into the problem. Now again, directly, what is the system? This particular horizontal part of the chain and the block is a system, no? And the mass gets added up. Then again, you get into the basic thing, velocity of link P equal to velocity of the mass getting added up minus velocity of the system, also velocity of the block here. I'll write it here, velocity of block. Now, what is the velocity of point P? The link which is at rest will get added up to moving system. No? So even this chain will have velocity V. Please, this is being connected. No, this part will be at rest. I don't know how to. Well, I'll put like this. This part is rest, and the yellow part will be moving. You should make a difference between this one. So this part is moving. And the link open is getting added up to the moving part. I think I can't. I'm helping beyond this. Not possible. You should be able to understand. So what is the velocity? And this is a block. B is a what? Block, that one. So what is the point P which is getting added up to moving part will be at rest. This is having velocity V towards right. So this is what V r. So what is V r now? Minus V. So what direction it is having velocity? Towards left. So shall I put how the thrust force should act? Towards left here. Any reason? Because mass of system is increasing. So thrust force will act in the direction of V r. How to calculate the thrust force? Again, what is the net force? What force is acting on the moving part? The same force will act on the link P which is getting added to system. So what is the net force acting on system? I think in this problem I'll try to show it because some of you are getting confusion. So here there's a link. On the link also I'll show it the thrust force. It is okay now? Net force, the link plus the link P which is getting added up to system and the moving chain and the block. This everything will become system. So what is P now? What we should say, link P is added to moving part of chain block system. So now what is the system here? I'll define that link P plus chain and moving block, that everything is system. So what is the net force on system? Will be 0. So can we conserve momentum now? Because this part was at rest totally. And this yellow color part is moving as usual. So what is initial momentum? MV naught. So applying net force on system. I'm writing very confidently and crystal clearly. Net force on system is 0, I'm saying. So initial momentum equal to final momentum. Initial momentum MV naught. Final momentum M plus what is the length of the part of chain? X. Lambda be the mass per unit length. Lambda X or what is the lambda not defined, no? M by L X. So total this is B, mass be M. Some X length is there. So M by L by X, that one, into this is V. Okay, I got expression for V. So what is V is equal to MV naught by M. Now I think capital M, small m, please take care. This is capital M, MXL. This is expression for the velocity at any point when X length of the chain is moving. But what is the question asked? Find the magnitude of acceleration of the block of mass M. How to calculate acceleration? Acceleration is due to thrust force only, no? So what is the equation? You can write it. Acceleration is equal to thrust force by what is the mass of system? M plus ml into x. We don't know thrust force. What is the thrust force? How to calculate thrust force? Thrust force is what? Vr dm by dt. Vr is what? Equal to v dm by dt. How to calculate dm by dt? Dm by dt. D by dt is equal to mass of the chain per unit length into x, no? So this should be equal to V small m L dx by dt. What is dx by dt? Should be equal to this one. So V m L V, or this will be mv square by L. Small m, capital M. Or if you want to write here dx, so what is m by L? M by L will become mass per unit length. L is the length of the chain given, so I'm writing it. So substituting this here, mv square by L will get the acceleration of the chain. So different ways of asking some questions. And what is M? Again, what is V? V again you should replace with this equation 1. Substitute 1 into will get acceleration. Then what about the tension? Tension should be equal T equal to MA again. Think on that one. Is asking tension at the point P. Tension in the rope at point P. At this particular point. So the tension should be equal to the total mass of the system. So I'll write down you mass of moving system into acceleration. So different ways of asking all these questions for you. Variable mass concept is being asked in different way. Okay, let's take the another one. Yeah, one more problem will. Let's take this one. A car has total mass. Read the question. I'll give the diagram. Let it very good problem where he's asking to bring your laws of motion into the picture. So initially this the so this is a fuel part. Rough, it may not appear like a car. Okay, assume it to be car. Total mass 50 kg. Gases are ejected. This is a gas. I'm just giving some small diagram. Now read the question so that you'll understand the equations what I'm going to write. What is the mass of the car? Has total mass 50 kg. Gas are ejected. Total mass of gas is 20 kg. So what is the mass of the gas? Is 20 kg. Mass of the car is 30 kg. So therefore the total mass will become 50 kg. And initially let it be a test. And there's a gas or a fuel, whatever you can say this one. Now there's a system. Initially this is T equal to 0. Now I'll ignite it. Then the car, what happened? Starts moving. The gas will be burnt. The gas will be ejected. No, that's what we are assuming here. No, so at any instant of time, now what will happen to amount of gas? That will decrease. In what action the momentum will be imparted towards right? Okay, let's go back to the all the things. What is the direction of thrust force? The gas will be ejected towards in the backward direction. VR. Then mass of system decreasing. Then in what direction the thrust force should act in forward direction. In what direction the friction should act? The friction should act backward. I'll show the resultant friction will act backward. When the car will start moving, only when I'll switch on the car, then as it, because of the variable mass concept, thrust force will act. So when the car will start moving, only when the thrust force is able to overcome the friction. Only when the thrust force will able to overcome the friction here. So the car starts moving. All of you read the question. I'll make it question a little bit smaller. Data, I'll make it this one. Yeah. Immediately will car will start moving. That is what we have to cross check. Fine. That is what we have to cross check here. how to do that one. So let's calculate the thrust force. How much of thrust force is acting, will calculate here. So now the car will move. F thrust is equal to limiting friction. So what is F thrust? F thrust should be equal to VR dm by dt. Then this should be equal to mu, mass of the car at any time t. So what is VR? I think some relative velocity from the backward, it's a relative velocity 20 meter per second. This we know. The rate of rejection of gases. So shall I write that dm by dt is 2, all of you? dm by dt is 2. Then mu is how much? 0.1. What is m? What I should write m? With the time, the mass of the system will decrease, no? Because some gas will be ejected. So therefore, what was the initial mass? 50. And at what rate the fuel is burnt? For every 1 second, 2 kgs. So minus 2 into t into 10. I'll calculate this. Allocated time. This time will be 5 seconds. So the moment you switch on the car will not move. The reason for the thrust force is unable to displace the car. Once what happened, as the fuel I continuously burn. So what happened to mass of the gases will decrease. Then 30 kg plus the mass of the fuel will be continuously decreasing. Once what happened, the normal reaction decreases. Means initially what is the normal reaction? N naught. This should be M1 plus M2G. Whatever the normal reaction here, this should be mg. So what happened to mass will continuously decrease, no? Then the normal reaction decreases. Then the friction will decrease. Once now the thrust force is able to overcome the friction, now it starts moving. So for t equal to 0 to 5 seconds, what is the state of car? Car is at rest. For t greater than 5 seconds only, it will start moving. Able to understand now? This is the thing. So now let's write equation. F thrust minus F should be equal to ME. So what is asking now? The time at which car starts moving. Okay, this is the thing. The first part. Then the maximum speed of the car. The time taken for car to come to rest. How to calculate maximum speed of the car? When the maximum speed will be attained? When the old fuel is burnt, no? When the old fuel is burnt, then the car will attain maximum speed. Am I right? Because thrust force will continuously act and the friction weapon will be decreasing. When the old fuel is burnt, then the car will attain maximum speed. How to calculate the time taken for the old fuel to burn? What was the initial mass of 20 kg is the mass of the fuel, and for every 1 second 2 kg is burned. So what is the time taken for the old fuel to burn? Let T be the time taken how to calculate this T. I'll come to, let's calculate that T. How to calculate this T? M naught minus 2T. Also like a mass of the fuel is how much? M1. Because you should not bring mass of the car. Car will not burn, only the fuel will burn. What is the mass of the fuel is M1? I'm showing here M1 minus lambda into T equal to 0. So what is M1? M1 is 20. Lambda is what? 2 kg per second. Now let me put a symbol here. It will be easy for you. So here also if you want, write lambda. No, 2 minus 2 into this. So what is T equal to? 10 seconds. So let's write now the equation. Ft minus F equal to Me. What is Ft? Thrust force. This should be equal to. And what is the acceleration? Ft by M minus F by M. thrust force is what? VR dm by dt. This is m minus what is F? F should be equal to mu mg. I'm making problem little bit simple by assuming things. So this will be VR dt. Recollect very first rocket propulsion, the same equations I'm bringing here, minus mu g. So what is the acceleration now? Acceleration will become dv by dt. Equal to minus vr dm by m. Adjusting dt on both sides, the equation will be dv is equal to minus vr dm by m minus mu g dt. Now the limits you have to be careful. Rocket propulsion concept only, I'm just applied it here. Initially, at t equals 0, what is the velocity of the car? It was at rest, no? This is after some time t. This is the thing. Initially at t equals 0, shall I start it, or t equal to 5 seconds I should start? Limits are very important. At t equal to 0 to 5 seconds, the car will be at rest. Now after 5 seconds, it will move. So therefore, the limit should not be 0, it should be 5. Then, what is the speed of the car? At t equal to 0 to 5 seconds, what is the rest? Then, what is the total time taken? 10 seconds. It will acquire maximum speed. What to do with mass? What is the mass of system? After for every 1 second, 2 kgs. At 5 seconds, how much of fuel is burnt? 10 kgs of fuel is burnt, no? Then what is the mass of system? 40. Finally, when all fuel is burnt, then what is the only mass of the car is left over, no? It should be 30. Able to understand the limits? At t equals 0, what is the mass of system? 20 kg fuel, 30 kg mass of the car. When all fuel is burnt, what is the mass of system? 30. Then it acquire final speed. Then at t equal to 5 seconds, till 5 seconds, how much of fuel is burnt? 10 kg of fuel. So from mass of system, remove 10 kg will be 40. Solving this will get Vmax.
Sir, one doubt, sir. Sir, thrust force.
I'll finish off problem, then you can clarify it. Let me finish
Okay,
off.
sir.
Log of 3 by 4 minus mu g t 5 by 10. So, or say this one. Log m 40 and this is 30. So this will be Vmax is equal to Vr log of 4 by 3 minus mu g 10 minus 5. I'll get maximum speed equal to 0.6 meter per second. This is the maximum speed attained by this one. After this, what will happen? There won't be any fuel left over. The car will happen will experience only friction force, will undergo retardation, and come to rest. No? So after this, 0 equal to Bmax minus mu g t dash. What is t dash equal to? After again it will move further some distance and finally comes to rest here. Once the fuel get over, it only friction force will act, then this is condition. Somebody asking doubt? Yeah.
No, sir, nothing, sir. Thank you.
Overall situation. So I think just you have to read that immediately it will not move. Only when the thrust force is able to overcome the friction, it will start moving. This is the idea of this problem. Some questions in variable mass, you have to be careful. Application comes little bit, you have to be alert. Computer, I think you have a chemistry class. Yeah. The last thing is time taken for the car to come to rest. Because after this, what happen? No longer thrust force will act. No, only friction force will act. I think I'll give one small diagram. It'll be easy for you. It has acquired a velocity. Only mass of the car is how much? M3, no? Or so this is M2. Mass of the car is M2. It has acquired maximum velocity and empty fuel. There's no fuel. Then a friction will be acting, and finally it will slide some distance, will come to rest. No fuel, no. This is at what time? Here, no fuel. That is what I'm writing directly, friction idea, no? So it will undergo retardation.
So time taken for it to come to rest will be 10 seconds plus 0. Like 10 seconds plus this time, no, sir?
That time.
Okay.
Total time, the time taken for car to come to rest means first 5 seconds you add up, then this 10 seconds, next the T dash. After what time it will come to rest? Now I'll switch on, then after what time it will come to me, so you have to add up all those times. 5, then this 10, then next T dash.
Okay, sir.
The fuel, the mass of the system decreasing dm by dt negative. Okay, finish. What's big deal in that one? Thrust force, what is the thrust force? VR into dm by dt, no? Therefore, that's why I brought it. Because how to calculate thrust force? VR into dm by dt. From there, I brought it. I'll close it. I have next class again. Thank you, all of you.
Thank you, sir.
Thank you, sir.
Thank you.
Tomorrow, I think festival is there. We'll see. Interested, I'll take class. If you're interested, I'll take class. Interested in evening, I'll take class. If everyone interested, then I'll take class. For me, no problem. Any day I can discuss. Okay, regarding tomorrow, we'll see. Thank you, all of you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank